Hello, I'm Bill Faulkner, and welcome to the SMRT video podcast series for MR Safety Week 2018. This series of videos was produced exclusively for the SMRT and MR Safety Week. In this video, we're going to review B1+rms and its use as a metric for heating with regard to implants and devices and their conditions of use. Now, historically, we've used SAR as the metric for device heating, but SAR is defined as a measure of the rate at which energy is absorbed by the body or the tissues when exposed to a radio frequency electromagnetic field. So it's an estimate, and this is important. It's estimated based on specific regions of the patient. It's also estimated based on assumptions of the type of tissue, the patient size, and the tissue composition. There's no standard which exists for estimating the SAR, and so it's going to vary with each MR system vendor. And the MR system vendors don't publish their proprietary SAR algorithms. So in summary, SAR is based on patient physiology as well as the imaging parameters selected for a particular sequence. Now, B1+, on the other hand, is based solely on the imaging parameters. Let's dissect, if you will, this terminology, B1+rms. Now, B1 refers to the oscillating magnetic field that's generated by the RF transmit coils. Coils and their design were the subject of the previous video in this series, and if you haven't seen that, you might want to take a look at that one as well, because it does discuss this in a little more detail. And from that previous video, you'll recall that the rotating B1 field can be decomposed into two counter-rotating subfields. So the positive sign in this term, B1+rms, refers to that positively rotating component that's responsible for exciting the nuclear spins and therefore tipping the tissue's net magnetization into the transverse plane. The term root mean square is a statistical measure. It's also known as a quadratic mean, and it is a way to average the magnitude of a varying quantity, such as positive and negative, which is what we have when we have a sinusoidal wave, like our RF pulse. And here's just another illustration similar to what you saw in the previous video, where the B1 field, indicated by the green line here in this diagram, can be decomposed into two circularly polarized or rotating components or vectors. And again, only that positive rotating component is what interacts with the protons, and that is what we're referring to with the term B1+rms. And again, to summarize this, if you will, just kind of in a single statement, B1+rms is a statistical measure of the magnitude or strength of the positive rotating component or subfield of the B1 field. And it's typically expressed in units of microtesla. Let's take a look at a clinical example of a device that has a B1+rms limit, and it's specified within the conditions of use. As you can see, this is a pacemaker with conditional labeling for 3 Tesla. Along with other conditions of use, the system must be able to report B1+rms. And the B1+rms limit will depend on the landmark that you select. I'll show you a slide here in just a second showing what we mean by where you landmark. Now, as a side, according to the device labeling, if the 3T system that you're using does not report or show the B1+rms, then the patient must be imaged on a 1.5 Tesla system using the SAR limits of use as described in the labeling. So here are the scan location requirements, and this diagram shows that if the landmark is above C7, then there are no B1+rms limits. You can do whatever you want to. If the landmark, however, is below C7, then the B1 plus RMS is not to exceed 2.8 microtesla. When you use the B1 plus RMS as a metric for heating, there are no restrictions with regard to SAR. The parameters which affect SAR will also affect B1 plus RMS. So, therefore, if you wish to reduce the B1 plus RMS, make changes to the sequence which will also reduce the SAR. So, for example, increasing the TR without changing the number of slices, that'll reduce the SAR and will reduce the B1 plus RMS. Or you could reduce the refocusing angle. That reduces SAR as well as, and again, B1 plus RMS. Or, for example, you could simply reduce the echo train length or turbo factor, depending on what your vendor calls it, and so on. Essentially, pretty much anything that will reduce SAR will reduce the B1 plus RMS. This is an example from a Siemens user interface showing B1 plus RMS. Notice that it's in the SAR information tab. Generally speaking, it appears all MRI system vendors whose user interface shows B1 plus RMS, they will display the B1 plus RMS information where you're going to find the SAR information. One additional bit of detail for the Siemens systems is the B1 plus RMS used in any given sequence will not show the correct value until you have performed the scan prep or pre-scan phase. Therefore, you've got to disable the automatic start feature so the system will pause for the user to initiate the scan after these prep phases. Only then will you see the B1 plus RMS, which will be used for the planned sequence. Here is a sample Philips user interface showing the SAR mode as well as the B1 plus RMS. On this particular GE user interface, the B1 plus RMS can be found at the bottom of the screen where the SAR information is also found. And that brings us to the end of this video of an overview of the B1 plus RMS. Keep a lookout for the very last video in our MR Safety Week video podcast. I want to thank you for taking the time to watch. I hope you found the information useful. So until next time, this is Bill Faulkner. Take care.